Okay, good morning, ladies and gentlemen. First, I would like to thank the organizers for inviting me to moderate this first session. I'm Jean-Jacques Tortora. I'm director of the European Space Policy Institute in Vienna. And it's a great honor for me to be with you today and to moderate this panel on the low Earth orbit constellation projects. Actually, this is a topic which already has a long history. The history of the constellations has started back in the 90s, initially with some projects like Iridium or Global Star and a few others, but Iridium, Global Stars in the 90s were the two which actually came to fruition, and actually both of them had, I would say, different fortunes. Both of them entered the protection of Chapter 11 and finally revived and found their public and their customership in, I would say, on grounds which were totally different from the ones which were initially targeted or identified. Then, of course, this gets a bit quieter. The enthusiasm of investors was a bit moderated by the I would say the mitigated success of both of these projects, and actually it revived a few years ago at a much larger scale. First with OneWeb. OneWeb is, and we will have the opportunity to know more in detail what OneWeb is about and what are the current perspectives with one of our panelists. Initially, I say OneWeb raised some skepticism, especially among the traditional space community, and some skepticism regarding the reality of the business case that such a project could address. But nevertheless, this gave and paved the way for a long series of record high announcements in terms of tens of thousands of satellites constellations, which also raised some concerns regarding the pressure that these projects apply on the space resources available, which never prevented most of them to actually get their license for operations. The most prominent of these projects probably is Starlink, led by the very famous Elon Musk, which was deployed at an impressively fast pace. And I must say that the skepticism has left place to some kind of urgency to act and to get and to position ourselves on these specific segments. So at this point in time, we still have really no concrete results to analyze or to look into in terms of economic evidence on the variability of these projects and on the reality of the mass market, because it's all about addressing a mass market that they target. But we have, I would say, more precise assumption. And our first speaker, Pierre Lionnet, who is sitting next to me, will certainly enlighten us with his, I'm pretty sure, insightful analysis of the perspectives ahead of this project, and it will be very interesting to get his views as director of research at Eurospace, and a long time, I would say, a colleague of mine, by the way. But second is that beyond the economic impact, we also have seen quite an impressive involvement of public players in this domain. which raises public concerns related to sovereignty, to autonomous access to connectivity, and in particular on the Commission side, Commissioner Breton has proposed an initiative in the name of Europe, and our second panelist, Christoph Kautz, who is head of unit for secure connectivity at DG Defis at the European Commission, will certainly also help us getting I would say, precise and accurate assessment of where this project stands at the moment. But back to OneWeb, who I said acted as the precursor here. Now OneWeb has evolved. Now it's a British-Indian-based company in which Eutelsat has massively invested. And it will be interesting to hear our third speaker, Chris McLaughlin, who will tell us more where OneWeb stands at the moment. But it's not just about the United States and Europe. The rest of the world is also proposing and moving ahead in this direction, and in particular China has also recently made some announcements regarding their intentions to deploy national mega-constellations. And Norbert Paluch, who will be with us remotely from China, will certainly be able also to bring to us some additional information on the Chinese perspective in this respect. Last but not least, then these mega constellations also raise a number of opportunities, risks and opportunities for manufacturing industry, and in particular for equipment supplier. And we have the chance to have with us today Nicolas Capet. Nicolas Capet is director at Anywaves, Anywaves, which is a French startup specialized in design and production of innovative antennas. And it will be very interesting to hear from you what is your assessment of the situation at the moment for for industry at large, but European industry in particular. But that being said, I would like now to give the floor to our first panelist. So Pierre Lionnet. Pierre Lionnet, what is your assessment of the space economy and the economic perspectives for these mega constellations?
Yes, thank you very much. Thank you, Jean-Jacques, for this kind introduction. Good morning, everyone. Yes, I would like to take some time to share with you a few, I would say, economic building blocks on understanding the status of constellation. I have prepared a set of charts. I don't know if they can be put on screen kindly. Yes, thank you very much. So I will quickly move to the very, very first slide. First, I would like to share with you some information. The first slide, please. Thank you very much. Share with you some information on what is the current costs of satellites. It's very difficult because a satellite is like a car. You know, you can buy a small one, you can buy a big one, you can buy a truck. So, you know, you cannot really compare. So we try to make a crude indicator on that. And just we look at the average cost per kilo of satellite based on the fact that everybody tries to launch the lightest satellite they can. And what is interesting to see is that today we have a number of, I would say, cost categories in satellites. The cheapest ones today are the ones which are already produced for the commercial market. And I would like you to focus on one simple figure. Today, a commercial satellite will cost between $50,000 and $100,000 per kilo to launch. So if your satellite is 10 kilo, maybe it will cost $500,000. If it is 20 kilo, maybe it may cost up to $2 million. It's a range, okay? Institutional satellites, military one, are incredibly more expensive, 6 to 7 times more expensive than that. So just focus on this first figure. Second slide, please. Now I would like also to share with you what has happened with the current trends in launch prices. So here you see those are average launch prices, again, in dollars per kilo. And what you see is that we have achieved a dramatic reduction in launch prices in almost 30 years. Launch prices have been divided by a factor 2 to 3, depending on the launcher. A lot of this cost reduction today, which is actually the price paid by the customer, we're not talking about production costs here, most of that reduction has been driven by Falcon 9 and SpaceX. So today, if you launch, in average, you will pay $10,000 to $20,000 per kilo. This is the cost of Rocket Lab. This is the cost of Ariane and Vega. This is the cost of the Soyuz, for the customer, of course. And if you go to SpaceX, maybe you can get $5,000 per kilo. But there are a lot of, this is the list price. There are a lot of conditions attached to that. So $5,000 to $10,000, maybe $20,000 per kilo to launch, $550,000 to $100,000 per kilo to build. So if you're an investor in space infrastructure, this is what you're confronted with today. It will be very difficult to buy something which is less. Let's move to the next slide here. Here I'm sharing other information on launch prices, just to know that it's not only my analysis. This is the excellent work done by Eric Kulu, who provides a lot of information online about launch and constellations. And he comes to the same conclusions as me regarding the value of launch costs. So this is the situation today. Now let's have a look at the future. Next slide, please. On this slide, which is not, thank you very much. On this slide, I have listed more than 200 satellite constellations which have been proposed today. Beware, this is a logarithmic scale. So you have hundreds of constellations which propose to deploy less than 10 to 100 satellites. And then we have a very few constellations which propose to deploy more than 1,000 and sometimes more than 10,000 satellites. But we have 200 constellations today. That's a lot. That are proposing to launch globally more than 50,000 satellites. That's huge. And this may happen in the medium term. We're talking about the next decade. Okay? Of those 200 constellations, there are more or less 150 which have received some funding. The others are, just on paper, on the internet, whatever. But 150 have received some funding, and quite a few have already launched, so that today we have already almost 4,000 satellites which have been launched on behalf of those constellations that we see on screen. Okay? Let's move to the next slide, please. Here, you see another list. This is the one from Doug Messier from Parabolic Arc. It's very actual. It shows the big ones and the ones which are confirmed. And we see now that not only we have those constellations which are promoting a large number of satellites, but in the recent week, we have seen other filings, other constellation proposals. So those are listed here. And one which has appeared even 2 days ago is not even listed, because now we have another proposal for 100,000 satellite constellation. We have the one from Greg Weiler with 300,000 satellites. So this is becoming completely crazy and probably getting out of hand. What I would like to understand now is what would be the mass impact of those constellations. And this is what I did on the right-hand side of the chart. Here you can see in blue the total mass already launched on behalf of those constellations, and in red, the total mass which is proposed to be launched only for the ones which have an FCC filing and some funding secured. Okay? So clearly what we see today, and please move to the next slide, is that most of the constellations are for communications. Actually, most of that is for broadband proposals. The total funding which has been secured so far by the constellation is in the order of $17 billion approximately. The top 10 attract 85% of that amount. The top 5 are worth 70% of that funding. Okay? One of the biggest constellations which is proposed today, we have no idea whether it's funded or not and what is the cost involved. It is the Chinese one, Guowan, the one which people tend to forget, which is a proposal as big as Starlink. And considering that China today is the biggest space power in the world, launching more than anyone else in terms of institutional satellites, I would like to say that this Chinese proposal is probably credible. Those 156 projects have deployed, as I said, 3,800 satellites. That represents 750 tons in LEO. The plan is to deploy 37,000 satellites, which would represent 10 times that much in LEO tonnage. If we consider that 90% of the capacity is still to be deployed, the total capex that would be required, looking at the price structure that we know today, it will have to grow a lot in the next 4 to 6 years, and it would amount in total to $150 billion. That is according to the prices we have today. Okay? The real price. I mean, if you go and buy a satellite today, it will not be $1,000 per kilo. It will be $50,000 per kilo. This is documented. This is the price paid by Planet. This is the price paid by Spire. This is the price paid by all those companies which have financial statements available. So clearly, if we consider that those constellations have a useful lifetime of 4 to 7 years, that means that the average capex for those projects to exist would require $25 to $30 billion every year. That is the capex requirement of this mega constellation proposal. And there is no way out of it. So clearly, how can we compare? Let's move to the next chart, please. Here we look at the current situation of telecommunication systems operator in the USA. You see that these guys invest every year $90 billion in infrastructure. And their requirement is to get in revenue, to justify this capex, 7 to 8 times that value. So that means that today, these guys, if they invest $1 in infrastructure, they expect the same year $7 to $8 in revenue. This is communication systems, broadband, cable, wireless, 4G, 5G. That's exactly what we have in the broadband environment. So let's move to the next slide, please. So if we derive that and we compare it to the $25 to $30 billion of capex expected from those LEO constellations, clearly my conclusion is that if these constellations have this kind of capex, well, the revenue expectations every year from those constellation systems should be in the order of $200 billion every year. $200 billion every year. That would be what would justify that investment in terms of capex. So then we can look, at many, many assumptions on the number of users, what is the possibility offered by those systems. Starlink would be 71 terabyte per second total capacity with 12,000 satellites. But most of that capacity is wasted over the ocean. It's wasted over deserts. It's wasted over areas where Starlink has no license. So what exactly is the revenue potential? Today, many experts assume that globally, a constellation like Starlink can, at best, expect to serve maybe 20 million users, but at the very, very best, with 40,000 satellites deployed. But not the 200 or 300 million that would be required to generate this revenue of $200 billion. So clearly, we are looking here at a situation which, from the economic point of view, is completely strange. Starlink today is 100,000 users. I don't consider this a validation of the case. And most of the constellation is already deployed in orbit. A lot of satellites are already decaying. And for the time it takes to deploy it all, the revenue is not there. So for me, Starlink is not validating anything except the technology. But the business case is not validated. OneWeb, I'm sad to say, but the project went bankrupt once after $3 billion leveraged. Now it's $5+ billion in capital and equity. And the business case raises a lot of questions because with the total throughput of 2 terabits per second, I don't see how it can justify this kind of capex unless the OneWeb satellites will last much longer. So the capex requirement would be much less. So let's move to the next slide, please, and I'm almost to the end. So today, let's make another calculation. The 750 tons deployed in orbit so far, if we look only at the total funding that was associated to that, was in the order of $23,000 per kilo deployed in orbit. That's the current average. So we see that we've already achieved a much lighter price structure than the one I was presenting before. That's factor 2, factor 3 cost reduction of launch in orbit, which is already exceptional. But is that cheap enough? I think that at that price, we are still facing the $150 billion capex and the $200 billion revenue requirement, so it doesn't work. If this can work, from an economic point of view, my analysis is that the cost must be driven down to $2,000 per kilo in orbit or less. And now let's move to the next to last slide. So if this is the new industry standard, the satellite people, the launcher people, they are able to roll out a system where eventually the cost of launching and operating an infrastructure is below $2,000 per kilo, even if the mass requirements to be launched increase significantly, even if we launch 1,000 tons a year in orbit, well, the revenue will be very, very small for the people who make the system. The satellite industry, the launcher industry will be dramatically reduced. I would like you to move to the next slide, please. So today, when I see this kind of chart with the global space economy growth, I don't understand what it means, because if the number of satellites and launchers increases significantly, it will be because they have become dead cheap. Dead cheap. That means that the total value of the market cannot grow. Maybe the value of applications will grow. Maybe the value of the service will grow. But even that, it cannot grow that much, because if it is not cheap, it will never meet its market. So for me, these current projections for the multi-billion space sector growth doesn't make any sense at all, because either there will be a revelation in terms of cost structure that will completely change the paradigm of space, and then we will see maybe volumes and, a blanket of satellites in the sky, which will be crazy in terms of debris, which will be a nightmare in terms of astronomy. But, why not? But only if those satellites are really like those masks, You use it and you throw them away. Otherwise, this will not work. So clearly here, the next slide is just a summary of my key takeaways. Very simply put, please can you move to the next slide? I don't see it changing. Thank you very much. So I'm just summarizing here my proposal today, but it's simply put in 3 major facts. Today, satellite launch infrastructure is still quite expensive, despite the fact that it has been very much reduced in cost. Those costs are the ones today faced by everybody who wants to produce and build a constellation. And those costs would require incredible revenues to be generated by this capex. And I believe that this cannot work unless the industry manages to completely change the paradigm, completely disrupt the cost approach. So thank you very much for your patience, and I'm looking forward to the conversation.
Thank you very much, Pierre, and well, I'm sure that your fresh look at these issues will raise a number of questions from the audience, and I expected you to be quite provocative, and you were up to my expectations, by the way. Now I would like to move to our next speakers, who is Christopher Kautz. I hope that Christopher is online. So, as I said, Christopher, you are head of unit secure connectivity and strongly involved in I would say, the supporting implementation preparation of this project the European Commission has proposed. So, Christopher, what are your views on these issues? What do you think? Where do you think is the right positioning for a European mega constellation?
Okay, thank you very much. Good morning. I hope you can hear me, although I'm in Brussels. Can you hear me? Hello. My colleagues apparently who are online, yes, but not the audience. Hello.
Yes, Christopher, we can hear you.
You can hear? Okay, very good. So I would like to make 4 points, and I know this is already bad with a French audience. Normally you should only have 3 points, so apologies, but I will make 4 points. So my first point is a little bit about the context, because I think that's important for you to understand why, as European Commission, we are working on this initiative. So a first general statement, I think we have to anticipate future challenges and potential strategic dependencies over the next 20 to 30 years. And when I say we, I mean the EU and policy as policymakers in particular. So in terms of context, the first thing I wanted to mention is about digital hyperconnectivity. So the Commission does now every year a strategic foresight report, and the latest one from this year, it has a whole chapter on digital hyperconnectivity, and the report says that this is one of the driving forces of technical transformation and will be one of the mega trends of the next decade. So the report also says that this will result in increased convergence of industries, products, technologies, and services, and the report calls for strengthening our capacity in that respect. So as a context, I think it's important to understand that there is this feature of hyperconnectivity. Second point of context is as it was laid out very well in the first presentation, there is a lot happening. International competitors are advancing fast, and we think as an EU we cannot afford to stay behind. I don't want to concentrate here so much now on the cases that are very well known, like Starlink, Kuipers, and so on and so forth, which are all in the commercial arena. But I would like to say that also in the governmental arena, there is a lot happening in terms of constellations being built up. So for example, we have the US DoD Space Development Agency, so-called transport layer, which are foreseeing a constellation. The Russian Roscosmos FERA project, which are also working on a constellation. So even in the public or governmental domain, there is a lot happening. So this is a second element of context. The third element of context, I think, is the experience we have or had and have with the pandemic. Because with the pandemic, we have seen that connectivity is very important, and connectivity was perhaps not always ubiquitous and robust enough. And with the pandemic, we have also seen that a certain autonomy for even such simple things like masks can become vital. So you can imagine how vital autonomy can be for technologies of the future or high tech in that respect. So in essence, we are now at a stage where we are let's say, we don't have no longer the luxury of a choice. Resilient connectivity is a strategic imperative, and it's one of the tools we have at our hand, and on which we should work on. I think in the EU we have a remarkable experience in developing connectivity, but we think we can still do much more, and at the moment our connectivity status doesn't match neither our legacy nor our potential. Now let me come to my second main point, which is about the objectives or what we want to achieve. So first of all, the first objective is to provide to member states, governments, governmental organizations, and to the EU institutions guaranteed and resilient access to a global SATCOM system, so offering governmental services. The second objective is also to enable for mass market the provision of high-speed broadband availability across the EU and further than that worldwide. And the third objective is to foster the union's strategic autonomy and avoid technological dependence. In essence, I mean, we are a little bit like we had 20 years ago with Galileo, where also people ask, but there is already the US system and the Russian system. Why now the EU does need to develop also its own satellite navigation system? And I think the clear answer today is, retrospectively, this was a very, very wise choice. Now, how do we want to do it, or let's say features of this initiative? So and I think the first point, and that's perhaps an interesting point, is we want to profit from the combined merits of a multi-orbital constellation with an emphasis on LEO, yes, but we also want to use either MEO and or GEO orbits. So I think that this is very important. Second thing, we want to make it secure because we want to offer governmental services on it. So secure in terms of cyber resilience, but also using quantum technology, cryptography. The third point, we wanted to be innovative, so by valorizing European new space. And we wanted to be scalable, so meaning adaptable to demand growth and technological evolution. We wanted to be synergistic, means complementing existing space and terrestrial infrastructures and communities of users. So I think this is important. We don't want to replace terrestrial infrastructure, so complement. And fourth, I hinted to that as well, it should have a worldwide coverage. We want to tap into innovative European digital technologies to make a difference by combining computing power and data. Now, perhaps the point which interests you most is about the process. So where do we stand with this initiative? We are what we have called for ourselves, you might call it differently, in a knowledge building phase. So, you know, we are undertaking a series of studies. We have one big study going on the architecture and the setup of such a multi-orbital secure connectivity system. We are now following up on the second phase of this study, which is to be completed by the year end, and notably on the most appropriate architectural design and exploitation model we are looking into. Additionally, you probably know very well that we published a call for tender for a study, or rather 2 studies, to include European new space into this initiative, and we will very soon announce the ones who have been attributed these 2 studies. Overall, and now I come to the legislative framework, if you want, we want to be able to propose to member states and the European Parliament a legislative proposal for this initiative in early 2022. President von der Leyen announced that in her letter of intent to the European Parliament and the Council. And it was now also included in the Commission's 2022 work program, this initiative. So this is where we stand at the moment. Thank you.
Thank you very much, Christopher. I think that you have very well set the scene to I would say, share with us the current status of the projects. I'm sure that we will have later on some interesting questions from the audience. But before that, I would like to complete our tour de table with our panelists, and I would like now to shift to our third speaker. So our third speaker is actually Norbert Paluch. So Norbert Paluch, so you are currently a space advisor at the French Embassy in Beijing. Very good to reconnect with you on this occasion after all these years. And Norbert, Pierre Lionnet has already put into perspective the very ambitious project put forward by the Chinese government. What are your views on that, and how do you see the current and short-term development of this project? We can see you, Norbert. We cannot hear you yet.
Recording in progress.
Sur le contexte chinois,
Effectivement, si vous regardez les ordres de grandeur des budgets.
Well, about the Chinese context, if you look at the budgets as we know them, so if you look at the budgets in the United States and in China, it's about $50 billion dollars for the US administration. So there's a difference between budgets. But clearly there's been a tremendous catching up effect for China in the last years in many regards. Yeah, you may be aware of that, but today China holds the absolute world record of successful launches, 42 against 48 for the United States. As regards also Earth observation, weather science, exploration of Mars, and also the development of LEO-based internet, for which China, however, seems to be lagging behind. So, considering this, the question is what's been going on in the last years? Where does China stand today? And what are our prospects for change? So I think we can say that there have been 5 major constellation projects in the last years. 3 come from state-owned enterprises, SOEs, so really juggernauts, and others come from private companies. Now, if you look at SOEs, there's the CASC, which is the China Aerospace Science Technology Corporation, which is the biggest institutional space player with a project of 300 satellites, but only one has been launched. It was launched in 2018. There's the Kasich Constellation. Kasich is the second largest institutional Chinese player, which is better known in the military area. There are plans to launch the so-called Rainbow Constellation, 650 satellites, but only one experimental satellite has been launched so far. The third player, the CTC, which is not that well known in the space industry, China Electronic Technology Group, which works more in the area of payloads, and which has proposed the Chengchang constellation, which launched 2 satellites in June 2018 and 19, and which has plans for 120 satellites. And also you regularly hear about progress made and tests made, the so-called 1+1+2 satellites. Now, if you look at the private sector, there's Galaxy Space, which is the unicorn, really, the space unicorn in China, which has put into orbit a satellite. So it was back in January 2021. And its objective is 144, possibly 150 satellites. And it's worked jointly with CASC and the other public corporation I mentioned earlier on. There's another newcomer, an outsider, which is not part of the space industry originally, and it's more interested in internet connection with vehicles. It is an innovative car maker. So you can see that in the last 4 or 5 years they've really been ambitious. However, the actual results are quite modest. And it's really difficult to see exactly where this is all going. Now, the third part of my presentation, Starnet, or SatNet, because the sinogram which is used for this is the same. So in 2019, analysts started to see some presentations of a Starnet project which at the time was driven by a telecoms operator that reports to the CASC that I mentioned. There were plans for 800 satellites, internet connection, data retrieval, 5G, and also the installation of stations on Earth, which suggests that there may not be inter-satellite links. Now, this project remained a dead letter. At least it's. The interpreting will be back in a second. Sorry, interpreting will be back in a second. We're just trying to get interpreting for people online.
L'année suivante, donc en mars 2021, en fait, il y a eu la première déclaration officielle avec des commentaires. En fait, c'était également la première année du plan quinquennal, 2021-2025. Donc, mention officielle du terme de Bourwang, Starnet, en disant qu'une société allait être mise sur pied et que la Chine décidait de lancer ce programme. Autant, en septembre de l'année précédente, 2020, il y a eu, comme vous le savez, un dépôt du dossier GW, vraisemblablement de China Star, auprès de l'UT, de près de et puis, parallèlement, ce qui est intéressant aussi, c'est que la Chine est
This is the interpreter. Can you hear the English translation? If so, can you please raise your thumb? Thank you. No, you can't.
Locales et des provinces, puisqu'il y a des initiatives qui ont été prises à Shanghai, à Pékin et dans plusieurs provinces de Guangdong.
Is it better now? Can you hear the English interpreting? This is the interpreter. Can you hear interpretation?
2021, la société a été officiellement créée, mais donc à partir donc des trois des dessins que j'ai mentionnés, avec un savant et évolutif d'ailleurs qui a évolué dans le temps, même depuis si peu de temps, entre des hauts représentants des trois sociétés. Sans que l'on sache vraiment, ou que soit là vraiment explicité qui était chef d'orchestre, qui était le maître d'œuvre, voire qui était l'opérateur.
What about the license was used 100%? This has not been specified, but it's been said that the three projects I've mentioned, I've seen Yangyan and then Changchun, have disappeared and substituted by another project. There was a lot of administrative problems, and only recently, the day before yesterday, as a matter of fact, the Information and Industry Ministry has declared they could multiply internet satellite messaging. We have more questions than answers. The Chinese authorities have set up a new structure, but we don't have any schedule. The Central Committee, all-powerful, allowing budgets to launch projects. Of course, there is a post-COVID-19 period which impacts
financial circles in China, but we miss technical specifications, frequencies, computing power. We could look quickly the objective. It seems that the scope at the national, international levels, there are 3 levels: protection of sovereignty, commercial, and industrial. In terms of sovereignty, defense and sovereignty, essentially, it's normal for China to own their own national system, institutional, in the 5-year plan, rational, to have a tool to serve the economic development. The commercial aspects is secondary or postponed at the international level. The international level is less important. We know we might have defense signals that could be shared with allies at the institutional level, especially on the Silk Road partners, but pure commercial aspects does not seem to be the #1 objective for China towards global markets. 3 or 4 operators, CCP, it's very difficult to identify. The main feeling is that CAF had the leadership, but today we get the feeling that ACCP is ramping up and another one is going down. It's very difficult among the various signals we have. During a satellite conference that was held some time ago, the mirror conference of what is happening in Washington, D.C., we have had a presentation of the 5 MTC project. They have presented with a few details. They have presented their Wang project of 58 satellites, and they need to launch 2 450-kilogram satellites next semester. It shows that CCT will probably become the leader. We mentioned that this power of 12,692, are we going to keep it to that? I do not know. I'm not sure this power is still valid or the right company. There is no freedom program that goes that far, and especially because the Chinese are confident, because there are a number of technological issues, number of terminals, and the complexity is much higher than the Beidou problem, which already has a lot of complexity issues. Very quickly, are they able to manufacture satellites? There are a lot of various companies, private companies, which are prepared. Kasich, that is lagging behind, but recently they have launched first satellites in a specially dedicated plant that could manufacture several satellites every year. And then another private company, they have announced the manufacturing of a plant to produce 300 to 500 satellites. Billy, they have produced the first satellites in a plant that could produce up to 5 satellites, and other plants which are not directly in the telecom or internet field, but they have the desire to come in terms of platforms, payload, and satellite manufacturing. We have in China all the means to manufacture these satellites. And what about launching them? Launchers which are not Chinese made. We have a range of launchers, March 8, 11, also with a retrieval Quadjo from Kasich. You have, which is a small launcher, and you have a range of launchers which have not been tested, and they might become ready in 4 or 5 years for launching centers, plus a maritime one, plus the beginning of a new in Mimbo space port, a commercial one that could be added to the.
To conclude, because we have still 2 more speakers online. Thank you in advance.
Donc voilà un petit peu les questions qui se posent. Donc
Those are the key questions in China. I do believe that China is concentrating on its in-house territory, national territory, in terms of sovereignty. And for Starnet, some companies will carry on private initiatives, will have more commercial ambitions, so have more doubts than.
Thank you very much, Norbert. A lot of information in your presentation, and actually quite useful, because all of this is not so much readily available to most of us here. And I'm sure we'll get back to you with a few questions, because this raised, at least for me, a number of questions that I would like to further address with you. But before that, our next speaker, who has already connected online, Chris McLaughlin. You are head of government and regulation affairs at OneWeb. So OneWeb is really at the heart of the reflections at the moment, raising a lot of curiosity about how now this project and this company will further evolve and adapt to this fast-moving market. So, Chris, the floor is yours.
Jean-Jacques, everybody, I hope you can hear me okay. And just to check, can you all hear me okay?
Est-ce que vous m'entendez?
Yes, we can hear you, Chris. We can also
fantastic.
hear the French translation. And by the way, Chris, while I'm talking, I would like to inform you that the Zoom English translation now is operating, and you can safely rely on it to get a translation. So thank you, Chris. The floor is yours. Sorry.
Thank you very much, everyone. First of all, can I congratulate all the speakers? This is probably one of the best conferences I've been attending in a very long time. The information that's being shared here is absolutely brilliant. Whilst, of course, I don't agree with everything Pierre said, it's fascinating to look at it. And Norbert's view of the Chinese challenge, as I would call it, fits in with some more geopolitical challenges that are facing there. And for Christoph, well, I've got a great news for you, Christoph. I can fix everything immediately, but you'd expect me to say that anyway. So a little bit of background, first of all. OneWeb started as a project to connect the unconnected. It's the second time that the entrepreneur, Greg Weiler, had tried to do this. His first was O3B, the other 3 billion, which was purchased by SES of Luxembourg and the EU. And they have turned it from a interesting but difficult platform into quite a powerful mid-Earth orbit MEO satellite platform. It's very good. In addition, he then created OneWeb. And in creating OneWeb, he caught the attention of a number of investors. Unfortunately, he felt that his objective was best served by selling out to SoftBank. And in February, March of last year, it seems a lifetime ago, COVID hit. And with COVID hitting SoftBank, they found that they could no longer fund the last $2 billion that was needed to complete the network. And I have to say that although it was awful for SoftBank and the other investors, it's probably one of the best pieces of news that happened for the LEO satellites, not least for what Pierre has been saying. The truth is that the bankruptcy process has refreshed OneWeb in the same way as Iridium has gone from Chapter 11 protection and bankruptcy through to the success that it is today, not least with the French-built Thales satellites and the BPI funding that helped all that to take place. The OneWeb of today is very, very different even to the OneWeb of a year ago. On the 20th of November, we will emerge 1 year from emerging from bankruptcy. And with the help of our friends at Arianespace, we will have now completed 11 satellite launches. We're heading for our 12th on the 27th of December. We are, I think, the biggest consistent customer for Arianespace. In addition to that, our satellites are built and have been designed by Airbus. They've done a phenomenal job for us with now 358 satellites in space. And the factory, which is located in Florida, it's a joint venture and was originally intended to try to attract other customers as well. The factory can turn out 2 satellites a day. And again, to Pierre's earlier thoughts, one of our satellites costs in the region of $1.2 million. So totally magnitude difference from the 14 years I spent at Inmarsat launching, as we used to proudly say, a satellite the size of a London bus and weighing 6 tons with solar panels the length of a football pitch. All of which is now, I should say width of a football pitch, all of which is now very different. Now for OneWeb, where have we got to? Well, to Norbert's point earlier, we almost ended up Chinese. In last year in the bankruptcy process, there were 3 Chinese bidders trying to secure OneWeb. Why? Because it's a strategic asset. And I think the EU has recognized the challenges as well, very, very well and very timely. The 3 Chinese bidders were each prepared to pay considerable sums to acquire OneWeb. And that was because OneWeb has the global spectrum priority under the International Telecoms Union. Why? Because we launched in KU, we have 2 filings, KU for the downlink, KA for the uplink. Our KA uplink is French, our KU downlink is English, British, and we combine the best of those 2 to deliver a service. Now, had any other buyer been able to purchase OneWeb, they would have been in a situation where they have ITU priority for the spectrum globally. And that was very attractive to the Chinese, who don't currently have any filings for a global system. Very attractive to certain US bidders who also didn't have filings. And ultimately was also interesting to a Canadian bidder who was looking to secure their position on LEOs. With that background, the debate became, well, why would we save OneWeb? And for the United Kingdom, the consideration was, first of all, isn't it American? Then why would we do this? And then what will it do for us? Exactly the same conversations that Christoph is probably having in Brussels at the moment. And the conclusion that was come to by the British government was this was a unique opportunity, that the priority, the technology capability, the opportunity to become a spacefaring nation of volume could not be missed. And so the UK government determined that they wanted to be part of it, but equally determined, we don't know anything about running telecoms companies. What shall we do? And in a very innovative approach, the Prime Minister approached Bharti Mittal, Sunil Bharti Mittal, who was known to be a very good operator of low-cost operating systems through his Airtel company. And the 2 parties agreed that they would make a bid for OneWeb. And we were fortunate to be purchased by those 2 parties for a total of 1 billion, which included all of the various costs. That has given us the best economics of any LEO. So although, as Pierre says, some 3.4 billion went onto the auditor's floor in the Chapter 11 process, the new company emerged with no debt. And subsequently, as you can see, if I step back from our shareholder flags, subsequently, we have attracted some 600 million from Eutelsat of France, some 330 million from Hanwha of South Korea. And of course, the original founding 500 million that came from the UK government and from Sunil Bharti Mittal. That 500 has been increased to 1 billion because of his confidence in where it's going. So in short, the company is fully funded. has no debt. And as we begin to get revenues, that flows straight to the bottom line in answer to the economics questions. So for us, we now start with year one nearly over. And with the launch on December 27th, we will have some 60% of the Gen 1 network up in space. And the intention is to complete the global footprint by the middle to autumn of next year. We all know the supply chain challenges that have happened across the world through COVID, but right now our suppliers have been doing a great job. Airbus have also been doing a great job, and we can see that the partnerships are working well. Now, for OneWeb now, again, to answer earlier questions, what is it? Why is it? Well, first of all, Christoph, I would say it's the ultimate manifestation of a European opportunity. There might have been a little divorce between friends, but it doesn't alter the fact that we're all still on the continent of Europe, that we all still have similar values and similar aims across an increasingly complex globe. I would argue that OneWeb takes the best of European technology already and secures a European partnership future. I would argue that blending OneWeb and SES-03B and Eutelsat GEO and SES GEOs gives Europe a massive advantage in what is becoming an incredibly complex world. I would also argue that you will have seen our filing activity is for 648 satellites, which I could say is a very responsible approach to the Space Commons and is focused on our desire and aim to leave no trace. We have a different style of operating to SpaceX, who have put their satellites in at 550 and who rely on the FCC exemption, which allows them not to deorbit, but to allow decay and to fall out of space. We have an active position, not least because being manufactured by a French manufacturer, French law requires us to deorbit. So I think we are very focused on the responsibility that we share in the Space Commons. So with regard to what can we do and how can we help, the answer is we are there already with Gen 1. We're there already with the spectrum. We're there already with European technology. We would happily reach out and seriously welcome a European flag into the backdrop that we have behind us because we are Europeans. We would seriously welcome developing with you use of Gen 1 immediately. And we would also, in a partnership, be prepared to work with you on Gen 2 so that the best of technologies are being focused into the UK and Europe, and that the aims of what we produce going forward are not, to the earlier speaker's points, simply communications. We could see a situation where Gen 2 has Earth observation capability, has PNT, position, navigation, and timing. Welcome a resilient backup to Galileo. Why? Because the whole focus now, I was at the Global MilSat conference in London a couple of weeks ago and listened to the American speakers from Space Force there. The whole focus now is on a multi-platform solution. As we saw last week, it is no longer possible for sovereign governments to consider, I've got enough with one thing. We have to all have everything. And actually we have to have everything fast. And we have to have the advantage of low latency LEOs coupled to the power of the large GEOs that Europe already has. And we should be thinking, how can we connect with intersatellite links, the next generation of our LEOs with the GEOs and with the MEOs to give a netted capability that can be of use to all citizens across Europe and also to our Five Eyes allies in a very complicated and contested world. I would, to Norbert's earlier point, Geely Motors, who of course own Volvo, were also one of those keenly trying to bid for the OneWeb spectrum back last year. They were, because they were commercial, they were actually told to stand back by the Chinese government. So it was all very challenging time. The focus that we have now is based around how can we better perform and support. And the answer, I think, is that, I'm just going to turn off my English feed here. The answer, I think, is that we do so by coming together. Imagine, if you will, that Baidu, the GPS for the Chinese, is also put onto their resilient LEO network. I'd say it's almost certain that they'll want to do it for their Belt and Road strategy. It's almost certain that they'll want to do it for their own resilience. What are we doing? What are we going? Are we going to put Galileo onto LEO? That should be a challenge and an enthusiasm for the Commission to think about. Are we going to have backup GPS resilience on LEO using Starlink and using OneWeb? I think that's a definite, given the challenges we've seen to GPS with Russian satellites being parked next to them to show what they can do, and with the jamming experience that we have in the Mediterranean around Syria, and activities from various countries at the moment that don't share our values. We should be taking the best of everything at the moment. We should be looking at what OneWeb can do with its established spectrum, with its technologies, and with its European partners to shape our future together. The Americans are doing it. The Chinese are undoubtedly doing it. As Norbert says, they have a huge launch capability, which frankly we're lagging on at the moment. And they have a huge determination, complete with a factory to build LEOs that they'd actually built before they had any LEO technology and any LEO aspirations sorted out. There's no doubt the Chinese government will push a LEO. I'm not sure how it's going to go or operate, because it won't have a global spectrum priority, but they will do it. So for the speakers today, for everyone that's thinking about where we are and what we're trying to do, the answer is that OneWeb's global footprint is an absolute reality. It's backed by the ITU. It will be complete next year. And we will immediately, to Pierre's point, begin the cycle of how do we develop generation 2 and what is it and how soon does it go up. And there, I think I probably slightly disagree with Pierre, but he'd expect me to say that. And in that our prospects are no longer based around the idea of the old model, broadband to everybody, what we're going to be doing. We are first and foremost a B2B focus and a B2G focus. We have no doubt that we will do well in connecting the unconnected and that we will do well in supporting aspirations, but we are focused on the commercial aspects of backhaul with using our LTE capability, which Starlink doesn't have, and using our ability to link up to the mobile operators and extend their range and extend connectivity, where we've seen in COVID that connectivity doesn't exist. You'll have seen our recent announcement with BT in partnership to connect the remote parts of Britain with the Prime Minister's election promises from earlier. And I know that
Chris,
most PMs are.
Chris, I'm sorry, may I invite you maybe to conclude on this?
Absolutely. As you can tell, I'm hugely over-enthusiastic on this. I thank everyone for listening to me, and I would just urge the European Union to think about how you can use your existing assets to powerful conclusion. Thank you very much.
Thank you, Chris. Actually, a lot of messages conveyed to the European Commission in your statements, and I think this certainly sheds light on the current state of play at the moment between the various European projects at stake. But now our last speaker is Nicolas Capet. So you are a French startup, and we have heard a lot of big figures. So I saw your eyes blinking. So this raises a number of I would say, opportunities for sure for companies like you, but what would be the challenges that you would identify to really properly address these markets?
Yes, good morning everybody. Thank you Jean-Jacques for inviting me, and I think it's very interesting. All the discussions we had this morning are very interesting because we are here to tackle this challenge of the price, of the capability to deliver quickly and develop and implement new innovation in space domain that are going to make it happen. And it's already happening. so many projects, numerous projects of constellations, so it's going to happen. I'm pretty sure of that, because also there is not only a question of economy, but also a question of strategy, independence, that are huge questions for all of us. So my name is Nicolas Capet, I'm CEO of Anywaves, and our job is to design and manufacture antennas for satellite constellations. Why? Because we saw this change in space domain with numerous projects, and now we are talking about hundreds, thousands, tens of thousands of satellites that are going to be launched in the next years. And it's something that is completely new in our industry, and this is the real challenge. This is the way we are going to make it happen, because the way we were used to develop technologies and industrial and producing I would say the different equipments on board very few big satellites a year, it's completely changing. Just to give you an example on what we did, we took a unique technology using 3D printed ceramic materials at the very beginning of Anywaves story, so it was almost 5 years ago. The TRL technology readiness level was very low. It was just an idea, a concept I had, and I decided to implement, to bring new equipments for this market. In 3 years, we developed this technology up to the qualification. Just to give you an idea, when I was working for the French Space Agency, and when we were thinking about implementing new technologies that were never used in space, the order of magnitude in terms of development time was 10 up to 15 years. So we divided by 3-5 this development time, and all economic actors know that time is money. The second point is that we have also reduced the price of our equipments compared to what was done traditionally. For that, I think it's because there is now, due to these volumes, hundreds, thousands of units we have to produce, it's a good way to reduce the cost, because volume is always associated to the cost. It's also a new way to think the equipment we are developing, thinking from the very beginning that we are going to industrialize it, to being able to produce, so it's not a mass production if we compare to ground industry, but we are definitely in the numbers of aeronautics. And I think it's something very important to understand that the way aeronautical equipment are developed completely, I would say, differently from traditional space equipment, thinking a lot in advance about industrialization, keeping the reliability, because space is not something, not a place in which quality or reliability is an option. Why? I think we are all aware about that. We are going to have tens of thousands of satellites in space. It was mentioned just before, we have to clean and preserve, make space sustainable. So the question of desorbitation and maybe sometimes grabbing some objects into orbit due to collisions or other events that are not very fun for all of us, is definitely a real point. So I think I'm part of a new generation of companies in space that are in that perspective. This new market, all these new opportunities, and the way we develop our products, our services, our equipments is based on that. So it's different from, I would say, traditional space that is definitely complementary to all these new projects, these new approaches. So our challenge is to become a real industry from space. No more making just art piece with huge technologies on long time, with satellites that have to operate 15 years, etc., that are going to still exist, because they are extremely useful, and this is what we use most today from space. But all these new concepts are going to complete and make space an even more big place for business, for applications, for use, and to tackle a lot of things we have to do, telecommunication, but there is also a lot of projects about Earth observation, navigation, etc., etc. All other aspects of the economical part. So, yeah, I think this is I would say, at least on our side, this is the way we develop and we propose our new products to be a part of all this new industry. And yeah, maybe just to conclude briefly, in order we get time for a few questions. I think the point I mentioned about sustainability is something important, because I took the parallel of aeronautic. In a plane, quality is not an option. We were aware about that because there are humans inside. In space, it's the same, because when we have a disaster in aeronautic, the plane crashes and okay, it's a disaster. In space, the disaster can stand many, many, many years in orbit. So I think we have to face a challenge and this is what happened in aeronautic at the very beginning. The first plane, there were almost no planes. We don't care where they were going, which altitude, etc., etc. No, we have perfectly regulated air traffic management. Tomorrow, we will need a space traffic management because it's not something we can just do it and see. No, in space, it's not like that. We all know that when we have an accident, a collision, some debris, it will stand a long time. So we have to prepare also ourselves in parallel to the implementation of all this huge constellation. We have to think how we are going to collaborate in orbits to make it sustainable and reach all the business opportunities and all the application and all what space is going to bring to humanity tomorrow. So I'm going to conclude on that point, and thank you again, Jean-Jacques.
No, thank you, Nicolas. Thank you, and for sure there are some security-related issues in operations in orbit, but there is a specific panel for that, and this is the next one, and I would like to avoid maybe addressing that for the time being. So we have a number of questions from the audience, and I would like to I'll take first maybe one that we got from one of our remote attendants, which was addressed to Pierre Lionnet. So you made a presentation and very detailed about the costs and cost of production, but having in mind that we are still in the early days of mass production of satellites, or at least at that scale, do you think that industrialization or industrialized production might be a driver to contribute to the required drop in costs, and to what extent? So,
well, I am wondering. I would like to take the opportunity of mentioning the quote by Chris McLaughlin before. So he said each OneWeb satellite is $1.2 million. So I don't know. I believe that this is the marginal cost of production. Otherwise, I don't understand why the company sunk $5 billion. So there must be something else. Okay, but even assuming that price, that's about $8,000 per kilo. Then you add 10,000 to launch. We are back to the 20,000 of the average I was mentioning before. So you see, for me, there is no mystery. These guys have achieved already some level of mass production. I take the example of Starlink. Starlink is announcing in the order of $300,000 per production cost per satellite. Okay, that's about $2,000 per kilo at launch. and they are mass producing them. I have no answer to that. The only thing I know is when we see financial statements, we will know what is the cost of investment, the cost of infrastructure, and the full cost of building those satellites, including the use cost of the infrastructure, the original investment in R&D, which can be capitalized. And for the few companies for which we saw the actual cost, thanks to the financial statements, which are space pure players, I'm thinking about Maxar, I'm thinking about Rocket Labs, I'm thinking about Spire, I'm thinking about Planet, I'm thinking about Satellogic. These guys are not achieving such low costs. Spire has produced in-house more than 400 satellites. Their production cost is $40,000 to $50,000 per kilo for satellites produced. So I don't know. How much can you achieve with mass production in terms of cost reduction? It's a good question today, but that doesn't change the requirements of space. Your satellite will need power. Your satellite will need to last, and not degrade too much in vacuum, support some level of radiation, be able to cope with temperature, so you will have thermal management, you will have propulsion, all this. So clearly, that's a very interesting question. I think that a lot has been done already. Again, let's keep in mind those figures. The average institutional satellite was $200,000 per kilo. The average commercial GEO spacecraft was in the order of $50,000 to $60,000 per kilo. And now, the current LEO constellation is in the order of $20,000 per kilo. Can we get one order of magnitude less? I would like to ask our friends here. You're making antennas. What is the price of your antenna? Do you consider that you can really drive down the cost by a factor 2 to 3, by 2 orders of magnitude? Again, I don't know. I'm only like St. Thomas. I want to see the facts. I want to see the financial statements. And this is where I derive my statements from. Thank you.
Thank you, Pierre. Any questions from our participants in the room? Yeah, I see one question in the back.
Bonjour Monsieur Lionnet, merci pour la présentation très intéressante. Philippe Coué d'Assaut Aviation. J'ai bien compris qu'à partir de $2000 par kilo, on commençait à avoir des choses intéressantes, mais on peut peut-être imaginer encore moins, et j'aurais aimé que vous nous dites que va-t-il se passer avec l'arrivée du Starship, parce que tout ce que vous avez montré concerne en fait des lanceurs bien connus. Mais que va-t-il se passer quand le Starship sera opérationnel? Parce que là, Elon Musk imagine encore des prix beaucoup plus bas. Donc, j'aurais aimé avoir votre avis là-dessus. Merci.
Maybe we can take a second questions and then we will address them from Mr. Rocagel.
Yeah, just a side. A question about Greg Weiler's latest initiative about constellation, his Salomon constellation. What about it?
Okay, Pierre.
So regarding Starship, Starship is a promise. So let's wait and see for the thing to work at least once. Let's recall that every Raptor engine is already 2 million in production. So that's already 80 million just for the motors. So at some point in time, it's not because it's reusable that it's free to use. So every time you use it, you amortize it. So depreciation, amortization are key factors in the total launch equation for the reusable systems. So reusable doesn't mean free. Personally speaking, when I see this device, I have doubts whether or not it will be operational. And then I would like to say one more thing. Launch costs in the past represented 20 to 25% of the total mission cost. So if you drive it down, you may enable new mission cases. So why not? But I don't think this will change radically the total use cases for space, even if you divide the launch cost by 10. We've already seen the price to launch divided by a factor at least 4 in average across the world. That has not really changed the launch demand. So the elasticity to price is very small. Regarding to your question and the new proposal from Greg Weiler, again, for the time being, there is very little information available. Honestly, I don't think this is really changing the equation either. Again, he's making this promise of very, very cheap deployments, but we need to see whether this can be achieved. So for the time being, again, we can, hypothesized for ages on what could be possible in the future. But today, we know what is happening. So we have OneWeb, this is happening. We have Starlink, this is happening. We have seen O3b, this has happened. We know that Iridium, Global Star are struggling with RPUs and are struggling with profit. So for me, again, the question is always the same. Can you drive CapEx down enough so that those business cases make sense? And if this is the case, would that be a good business for a company like this one? It all boils down to the same points.
We'll come back to, we'll invite you to address these two invitations that Pierre Lionnet made to you. But then first, before that, I would like to maybe to take another question, which is this time addressed to Chris McLaughlin, because we have been discussing a lot about the cost of the in-orbit infrastructure, but what's at stake is also the cost of the ground infrastructure and of the terminals. So the question addressed to you is very, very, I would say, straight to the point. What are you doing in order to achieve a drastic cost reduction in the production of the terminals that will be used to get access to your service?
Jean-Jacques, that's very kind of you. I'm just going to turn off my English translation. Very kind of you to ask the question. And the situation is this: we are building out the ground infrastructure at the moment. 8 of the 9 control centers, the SMPs, for the first stage of our launch are already complete. The 9th will be in January. That's in Greenland. The next batch, 14 or 15 in total, are in various stages of build across the footprint. And in total, depending on the number of countries that we're allowed to access, we will have up to 43 ground stations. There's a major difference between OneWeb and Starlink in that because we're out at 1,200 kilometers, we see more of the Earth with fewer satellites. 1, it has less impact in space, but 2, it also means we need fewer ground stations, so there's less impact there. Coming straight to the point on the terminals, our first terminal is a dual parabolic from Intellian, the Korean manufacturer. That is a pricing of around $10,000 to $12,000. But that is really a sort of industrial and locational thing. You would put it in your airport, in your fishing port, in your connected small village, remote village. We are also developing a number of other terminals. We have the compact ESA, which will be a flat plate electronic terminal. And the target price for, if you like, the smallest consumer product is in the region of I always like to call it the price of an iPhone, which is about $1,100 to $1,500. None of us ever think about the price of our iPhone. It's slipped into our service contract. And the way that we work is not selling direct, which is the SpaceX way, but working through partners. So we would assume that those using our service will get their terminal within a bundled price.
Okay. Thank you very much, Chris. I think that you have very perfectly addressed the question. And now we'd like to conclude maybe with Nicolas. So reduction of price of 1 order of magnitude, easy to achieve, yes or no? A yes or no reply.
Easy, no. Easy, no. Doable, I think yes.
Okay. So I'm sorry, we are now, I've reached the end of our time slot. I'm sorry, I still see some hands rising to ask questions. But no, the organizers invite me to conclude this panel on this last statements. I would like to thank you all for your attention. I would like to thank in particular our panelists for having shared with us their views, their thoughts, and a lot of food for further thoughts actually on the table. And I look forward to further contributing to this debate along the day. Thank you all.
Thank you very much.
Thank you.